So Chapter 9 discusses exponentials and logarithms. This will be the final chapter that we discuss in this course. Chapter 9, we're going to start off with exponential functions, graphing them, and then we'll move on to logarithmic functions, and then we'll talk about two specific types of logarithmic functions, namely the natural logarithm and the common logarithm. We will also use all of this information to solve applications of these types of problems. So, to start off here, we need to distinguish between a power function and an exponential function. Now, a power function is what you have seen for most of your algebraic career, and this is any function of the form y equals some constant coefficient times x to a power. So again, here c and n are real numbers. So this is when you have x to a power. What we are going to start talking about now are what are called exponential functions, and exponential functions take on a different form. They take on the form of some constant times, usually use a as your number, to an x, a variable exponent. So in this case, c and a are real numbers, and x is a variable exponent. Now, let's try an example of graphing one of these functions, these exponential functions, by plotting some points. So, we can pick some points like we usually do. You can pick any points that you prefer. In this case, I want to pick at least 5 points just so I get a clear picture of what this graph looks like. So I'm going to pick -2, -1, 0, 1, and 2. And we've got a little bit of room over here to the right if we want to work these out. So if we have 2 to the -2, for instance, remember that a negative exponent does not change the sign on the number. It simply flips it over the fraction bar. So this is really 1 over 2 squared, which is 1/4. Likewise, if we have 2 to the -1, that's going to flip it over to be 2 to the first, which is just 1/2. If we plug in 2 to the 0, well, that's anything to the 0 power is 1. If we have 2 to the first, this is just 2. And if we have 2 squared, we get 4. Now, anytime we are graphing, we want to make sure that we label our axes. So I'm going to say that this is 1 and this is -1. And I'm going to go about plotting my points now. So at x equals -2, I am up 1/4, which is not very far. At -1, I'm at 1/2, which is not much higher than what we had in the previous one. And then at 0, we are at 1. At 1, we are up here at 2, and so now this starts to grow really fast. At 2, we are up at 4. So now if we connect those dots in a smooth curve and kind of continue it on in its trajectory, we end up with a curve that looks like this. So notice that it is very shallow. It's leveling off here as we go off to -infinity, and it is increasing rapidly as we increase x. Example 2 is very similar. I would like you to pause the video at this point and complete the graph for example 2, which is y equals 5 to the x. So if you work through this problem, you should have gotten a graph that looks similar to this. Notice here that for my y-axis, I chose a unit of 5, just because that 5 squared ends up being 25, so that I can fit everything here on my graph. If you notice the difference between this graph and the one above it, This one increases much faster, and this is even with a changed scale. So this one is going to increase at a much faster rate, and that has to do with the fact that the base in this case is 5 compared to 2. You can see how much faster that increases. Got a couple more examples here of graphing. So we can also graph fractional bases to a variable exponent. And I'm going to do a couple of these, and then I'm going to have you pause the video to continue. Again, if we plug in -2, -1, 0, 1, and 2, then, for instance, if we take 1/3, and we make sure to put this in parentheses because we're raising the whole thing, not just part of it, and we're raising this to the -2. So in this case, this means that we flip it over, so we now have 3, and that exponent becomes 2 because we flipped over the fraction. So this ends up being 9. So now I want you to pause the video at this point, plug in the rest of the numbers we have here, and graph the function. So for this example, you should have gotten the remaining values to be 3, 1, 1/3, and 1/9. Again, if you plug in 1/3 and raise it to the respective powers. So if you graph this function now, we start off very high, and then we decrease to kind of level out at 0. So if you can kind of infer from this, if we have a base that is greater than 1, then we're going to have this rapidly increasing function. If we have a base that is a fraction between 0 and 1, then this is going to rapidly decrease. Again, it's going to start high, and then after we cross the y-axis, it is going to rapidly decrease. We've got one last example of graphing here. So again, let's plug in our same values, -2, -1, 0, 1, and 2. So if we raise 3 to the -2, well, that's really 3 squared, which is 9, because that negative becomes a positive. Likewise, if we have 3 to the -1, then this is just going to really be 3 to the first, which is 3. Continuing, we get 3 to the -0, which is just 0. And anything to the 0 power is 1. 3 to the negative, and we're plugging in 1. So this is really 3 to the -1, which is 1/3. And likewise, if you end up with 3 to the -2, well, you would flip this over, so it would be 1 over 3 squared, which is 1/9. So if we plug these values in, 9, 3, 1, 1/3, and 1/9, and we make sure to label our axis. Notice on the one previously, I made the y-axis 2 so that I could fit everything on. I'm going to do the same thing here, so I'm going to make this, the x-axis go by 1s, but the y-axis go by 2s. And in that case, I'll be able to fit all of my points on. So in this case, if we plot our point, -2 is at 9, so 2, 4, 6, 8, 9. It's going to be halfway in between. We follow over here to -2. At -1, we're at 3, so 2 and then halfway up is going to be 3. At 0, we are going to be at 1, which would be halfway up to 2. At 1, we're really small here, so it's almost barely showing up. It's right along the axis here. Same thing for 1/9. And then again, we connect these dots, and we see that this graph is rapidly decreasing. Now, if you look at these two graphs that we just did, you should notice that they are identical. The values that we put out are exactly the same. The graph is exactly the same if we've done it correctly. And so this should kind of tell you that these are really the same function, which makes sense. If you rearrange 3 to the -x, well, if you just consider that negative exponent, if you consider this to be 3 to the -1 times x, then 3 to the -1 is really 1/3 to the x, which is the same function you have up top there. So these are really the same function. So anytime you have a whole number base, or a number greater than 1 base, to a negative exponent, it's really like looking at what would happen if you had 1 over that base as a fraction between 0 and 1, and then raising it to the x power. So those end up being the same function. One final thing I want to do in this video is to talk about how we can also graph these in the calculator and find these values. So if we have our calculator, again, just a reminder, is that if we want to go here and graph, we always go up here to y equals, and we would put in our function as we see it. So for instance, this last one would look like 3. We use the caret button here on our calculator if we've got a graphing calculator, and then we use negative, and our variable up here is x. And then we hit the graph button. And you should see here how we end up with a graph that looks very similar to what we have listed here, what we have drawn on our sheet. So again, you can play around with that depending on what you're trying to input. If I wanted to go back instead and do the one up above, which was 1/3, I would make sure to put it in parentheses, 1 divided by 3. And then I would hit my caret button again to get my exponent, and then the exponent of x. And again, if I hit graph here, it'll show up on my graph, and we can kind of transfer over. You can either do that by tracing points, using your left and right arrow buttons, putting in actual values to find that 2 is, yes, 1/9, which is the decimal approximation 0.11111. And we can find our points that way to plot on our graph. You are not required to have a graphing calculator for this class, but if you do have one, this is how you would go about doing it. You will need a graphing calculator if you go on to Tech Math 4. So this concludes the video for the first half of section 9.1. The next video will talk about some applications of these exponential functions.